Hello mathematicians, welcome once again to a video. This one is on chapter 5e, which is graphing straight lines, and as I've indicated in my news, it's one of my favourite topics. I just find it straightforward and easy to understand. I'm hoping that you will as well. Now, none of this material is new for you this year. Some of it we may have skimmed over a little last year, but it is not new. So if you think you know what you're doing, just get stuck straight into the problems out of the textbook. But for those of you who need a bit of a refresher, let me have a look at this. Part B on this particular page, this bit over here, you might find a little bit tricky and go, oh, what do I do with that one again? So I'll run you through that one too. So first example here, which is example 14, is all about is this particular point. Now, that's a set of coordinates. So minus 2, 7 is a set of coordinates, and it's asking whether that point is on this line. Now, you need to remember that this equation here represents a straight line on the Cartesian plane. And we're going to draw some a little later on. And so it's asking, is this point here actually on this line, if I call it a line rather than an equation? And we can check that rather easily. So let's make a start. The way that we do that is that we substitute in the x value and the y value into each of the equations and see whether it's true. So let me do that. We know that the 7 there is the y value, so I'm going to put it straight into here and go, so the x is the minus 2. So what is 7 equal to minus 3 lots of minus 2, so that's our value for x, plus 1. Is it true? Oh, let's have a look. On this side we've got 7, and we'll compute what's minus 3 times minus 2. Minus times a minus is a positive, so that should be 6. And we've got 6 plus 1, and you can see that, yes, it will be true. So 7 does equal 7. And so, yes, the point is on the line. Point, I'm just going to summarize this, on line. Okay. Now, we would imagine that this next example here will be not on the line, perhaps, because they always like to throw in a different option. But this particular format over here is, like I said, a little different to what we're used to. For this particular example, it doesn't matter, okay? But when we go to graph it in a bit, we'll see that we do need to rearrange it to put it back into a standard format. So let's just substitute in for now. We know that our x value, so we go 2 times minus 2, because that's our x value, plus 2 times our y value, which is 7, equals 1. So is this true? 2 times minus 2 is minus 4. Is minus 4 plus 2 times 7 is 14. Does it equal 1? Well, you're going to pick in a minute that it's not the case. If I simplify this side, I get 10. Minus 4 plus 14 is 10. 10 equal 1? I don't think so. So I'm going to put a line through there. And we know that no, not on line. Okay? So the point, that particular point, minus 2, 7, is not on this particular line that equation represents. Okay, I hope you've got that, and it should be simple enough. I'm going to flick through to our next problem here. This is example 15. This is part A of example 15, and we're going to sketch this equation. So y equals 2x minus 1. I hope you can read that right there. Okay, now example 15 in the textbook actually says, first find the gradient and the y-intercept and then graph it from there. Okay, so we're going to do that, and I'm hoping I'm going to write this down. Y equals, a standard format is y equals mx plus b. This is in the right format. We've got a y out the front, and we've got we've got our x, that x there represents this x here, and we've got a 2. We can see that the m represents the 2, and the b represents with this number here. And we have to always remember to take into account that minus 1. We also need to remember that this m is the gradient. So let me write that in there. So that there is the gradient. I'm just going to write grad. And this bit here becomes the y-intercept. And I know that you'll remember that I used to just write y-int for y-intercept for the b. And so from this, we can see quite clearly that the gradient equals 2. So I'm going to write that down. Gradient equals 2, and y-intercept equals -1. Now, before we go about graphing this thing, we need to remember one extra piece of information, that gradient equals, I'm going to write it here, rise over run. And you'll remember too from last year that I like to put the 2, this 2 in here, into the format of a fraction so that we can recognize which bit is the rise and which bit is the run. So let's do that. The easiest way of making a whole number of 2 into a fraction is to write it as 2 over 1. So, you know, that bit there is the rise. Hope you can read that. And that's the run. Ah, dear me. I don't know what's happened to my writing. R-U-N. Much better. Now we're going to graph this thing. We've got our 2 bits of information, y-intercept, and we've got our gradients down here. So I'm quickly going to put a Cartesian plane together. 1, 2, 3, 4. I hope this is going to be enough. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And this just needs to be a sketch. We know that this vertical axis is a y-axis. This horizontal one is our x-axis. So let's plot this. First step, number 1 step, is to plot that thing there, which is our y-intercept. All right, we know that this line has to pass through this point. And a y, so here's your y-axis. Where is it -1? Well, it's right here. And I should choose a different colour pen, shouldn't I? I can do this. It will go through this Cartesian plane at that particular point. Now, the rise over run here, if you remember correctly, we start from that point, and the first thing I do is I'll rise 2. So I'm going to go rise up 2, and then I will run 1. So run 1 means go to the right, always go to the right, and I run 1. So my second point will be in here. Now, a lot of people stop here, and this is how I used to teach it as well. You can draw a straight line through there, and there it is. But I'm going to put another point in place. I'm going to rise another 2. So I'll go with my red pen this time. 1, 2, and I'm going to run another 1 across. And so my third point will be here. And you can see they're always going to be in a straight line. Okay? And I'm going to draw, rather rough-handedly, a line through there. So this is graphing straight lines. That's supposed to be a straight line. And there is my solution for this one. Okay, as simple as that. Firstly, find y-intercept. Secondly, find gradient. Convert it into a fraction if it's not already. And then first plot the y-intercept, and then use, so I'm going to put in number 2 in here, then do the gradient from there on. Okay, let me do the next example. Okay. Example 15b is sketch 2x plus 3y equals 3. Now you'll notice here that, it's not in our standard format. It is not a y equals something, you know. So first thing we need to do here is convert it into our standard format, which takes a little bit of time. All right? So we want just a y, so I'm going to write over this side here, we want it in the format of y equals mx plus b. So what we need to do is get rid of all of this 2x on this side. We need to get rid of that 3 as well, and then we'll be in a position where we've got a y equals mx plus b. So let me do that. And I'll follow my own advice. I'll get rid of this 2x, and I do it by, I'm going to subtract 2x from both sides. Subtract 2x, subtract 2x. And I end up with, 3y, the 2x disappears. 3y equals minus 2x. I'm going to put it in the front, and you'll see why in a minute, because, and then there's a 3 on this side as well. You'll notice that it's starting to look a little bit more like this standard format. I've got y's on one side, and I've got my something x's, and here's my something x's, and I've got a plus something on the end. So we're getting to it. The one last thing that we need to do now is get rid of this 3 on this side. Because that's 3 times y, we want to divide by 3 to get rid of it. But whatever we do to one side, we have to do the other. So we end up with y equals minus 2. Yikes. Minus 2, can you read that? No, I'm going to redo that bit. Minus 2 on 3, because we had to divide it by 3, x. And then I've got this 3 here that I'm going to divide by 3, and I end up with plus 1. So I've divided both bits over that side by 3. Now, where do I go from here? I find my y-intercept and I find my gradient. So let's give this a go. So we should know now that this is my, so that bit there is my y-intercept and this bit here is my gradient. So I'm going to write gradient, and this time I'm going to write rise over run first equals -2/3. And I'm going to put the minus at the top. I'm going to assign the minus to one of those, and I like to put it at the top. And then my y-intercept, where am I going to write that? I'll write it over here. Y-intercept equals 1. All right. So I've got my 2, and you'll notice here that we do have our gradient already in the fractional form. So my rise is going to be -2. Am I going to rise 2? No, because that's a minus there. I'm actually going to drop 2. The minus indicates that rather than rising, I should be dropping 2. And my run will be 3 along to the right rather than just 1. Okay, so let's go to graphing. I will put it together. 1, 2, 3, 4, 5. I hope this is going to be enough because I haven't practiced it, but I think we shall be fine here. 2, 3, 4, 5. Again, I will label the axis as y and x over here just to help. Okay, where do we start? You know where to start. First, we plot our y-intercept of 1, and that's pretty easy. Y-axis, there we go. There's my red pen there. Second thing that we do then is we go the rise over run from the gradient. And we know that our rise will be -2. Well, let's do that. A rise of -2 means we drop 2, drop 1, drop 2. And we're going to run the 3 along. So 1, 2, 3. And I end up at points where I can put another red cross there. Am I going to do it again? No, I'm actually going to run out of space. So I'm going, with 2 points, and if I know that it's a straight line, I can just draw a straight line that goes to the best of my ability, which isn't too bad. Look at that. Looks pretty good. There is the line that represents the equation 2x plus 3y equals 3. Okay, right. A little bit more complicated than the first example, example A, but the process in finding the y-intercept and the gradient once we had the equation is the same as last time. Okay, let's move on to the next one. Example 16. Now, this one says sketch by finding x and y intercepts. There are 2 ways of sketching. This is the other way of sketching. All right. I don't like this way quite as much because it's a little bit more mucking around in getting our solution to then plot. But actually, when we go to plot, it is really easy from that point on. And some of you might like this better. So we're going to find the x and the y intercepts first. And that's, yeah, we'll see how we go with that, okay? There is a particular process. In this particular process, we have to say, yeah, look, I will go through the theory. Here we go. I'm going to put my, my set of axes here together. Now, if we want, and this is the y-axis, and I'll go 1, 2, 3, 4, 5, 6. I will draw my little lines on the axes. If I want to find where it crosses the y-axis, and I'll show you in a minute when I choose my little pointer. Remember how that's the y-axis. If I want to know where it goes through that y-axis, I've got to say where it happens when x is 0. See, this is my x-axis here. X is 0 right there. All right? And where x is 0, that's the y-axis. So if I choose my x value to be 0, then it tells me, or the equation will spit out to me, what my y-intercept will be. So that's what I'm going to do. I'm actually going to, let me get this right, say when x is 0, so my first step is when x equals 0, then I put 0 into the equation, then I end up with y equals, my pen's not wanting to write, y equals 2 times 0 minus 8. And you'll be able to see that y then equals 8. Oh, sorry, negative 8. Okay, so that is actually where the line will go through. Now I've got negative 8 here, and I don't have it on my axis. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So it's going to go through down here somewhere. I haven't drawn it large enough. Okay, there's another line in there, that's -8. And I'm going to go minus 8 there just to remind myself. So the line's going to go through the axis at that point. So similarly, if we want to find a, where it goes through the x-axis here, then we need to say that's where y equals 0. So y equals 0 at this point. That means that we're actually finding a value along the x-axis. So to solve this one, let me go and get my pen ready. I'm going to say when y equals 0, then I'm going to place y equals 0 into this equation to get 0 equals 2x minus 8. And this is where it looks a little messy, and that's why I don't like it. Once we have an answer, this will be easy to plot. So to solve this, then I will add 8 to both sides, plus 8 to this side, plus 8 to this side, and I'll end up with 8 equals 2x. And then I'll get rid of the 2 by going divide by 2, divide by 2, and I end up with 4 equals x. Or you could say x equals 4. Same deal. All right, so there is my x intercept. You've rarely heard that before, but that's my x-intercept. So I know that my line's going to go through a value of 4. 1, 2, 3, 4 at this point here. Okay. And now that we've got 2 points as defined on the axes, I can draw a line to join them up. And that's pretty rough, but it'll give you an idea. I do like to stick arrows on the end of my lines because they don't just stop there, they go on forever. This is a line rather than a line segment, or a segment as you might say, okay? So once, I know there's a bit more mucking around, once we've found our intercepts, it is very easy to plot from there. Some of you might like that a bit more. Let's do another practice with something that's a little bit harder. Go to this next one. You'll notice this one here isn't in our standard formats, all right? Now, it matters less with this method because we're trying to find y-intercept and we're trying to find the x-intercept, all right, and then plot it. But the process is the same. I'm going to start the process off the same. Which one did I do first? X equals 0. I'm going to place 0 in there. So the 0 is going to go into where that x is there, and it's going to be minus, the drawing's not great shot at the top, minus 3 times 0, which you know is going to be 0. Let me put the 0 back in there, keeps going away. Minus 2y equals 6, which is the same as saying, and I'm going to cross that bit out, minus 2y equals 6. Now to solve that, I would divide both sides by minus 2. Divided by minus 2, divided by minus 2, and I end up with y equals, so 6 divided by minus 2 is minus 3. That is my first intercept, and that's the y-intercept. And we do exactly the same, and I'll do it, and you might be getting bored of this. When y equals 0, and we're going to put that into the equation, all right, we end up with minus 3x minus 2 times 0 equals 6. To simplify it a little bit, we end up with minus 3x, and we know that this bit here is 0, equals 6. And so I'm going to divide both sides by minus 3, divide by minus 3, and I end up with x equals minus 2, and that is my x-intercept. Now, and the process from here is simple, you know, and that's where this particular method is simpler to plot than when finding the gradient and y-intercept. It can be a bit more mucking around, trying to, there's a lot of clicking going on here, isn't there? Trying to find out x and y-intercepts. So I'm going to call y up there, x out here. I'm going to change the color of my pen, and I'm going to plot an y value of minus 3, done, easy. An x value of minus 2, done, easy. And all I have to do now is join them up, and there we go. Not very good, but you can see what it's supposed to look like. That one was a bit off. Yeah, so that one's a bit off. So if I was to draw that again, I'd draw it a little bit further down to go through. But that's the process. I think you can do that. Not too difficult. Now on to our last example, example 17. And this is about lines with only one intercept. We did this last year. I'm going to go straight to drawing my set of axes. I'm going to draw each of these lines on the same set of axes. We'll see how we go with this. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hopefully that's enough to plot all of these. That's my Y, that's my X. All right, make it nice and clear. Doesn't take long to put those labels in there, helps us understand it. Now we have our 3 equations to plot. So let's start with our first one here with Y equals 2. Now I'm going to do that by, I'm going to choose a red pen here. Y equals 2 is true for wherever Y is 2. And the most obvious place for that is on the Y axis here. You will find that on that piece of axis, the Y equals 2. It makes sense. All right, but you'll know, or you'll pick up, hopefully, that here Y also equals 2. So if I was to find every coordinate point, which is made up of X and Y coordinates, the Y coordinate for every point along here would be where Y equals 2. Okay, so I could actually draw a line through there to represent all of those and say that is the line that represents this equation of Y equals 2. Isn't that cool? And because of that, you should be able to then pick, and I'm going to choose a different colour pen here, if X equals minus 3, what does that look like? Well, let's have a look at the X-axis here, and we find that X equals minus 3 is right at that point there on the X-axis. But you'll also notice that for every coordinate point, as we go up and down here, the X value for each one of those is also X equals minus 3. So joining all of those up, you'll find that you end up with a line that represents the equation here of X equals minus 3. Okay, the last one here is a little bit different. We tackle that one a little bit differently. It looks similar to our standard equation of Y equals mx plus b. B won't draw on the end there. Y equals mx plus b, except for the fact there's no b. Where's the b here? There is no b. Okay, we have our x. We have a number that's in front of the x, and that represents our gradients, but there's no b. And so because of the fact it's got no b there, y-intercept equals 0. So I'm going to write y-intercept equals 0. And this, because it's the gradient, is rise over run. And if we were to make that into a fraction that makes perhaps a little more sense, I'm again going to write minus 1 over 2. So minus a half looks like minus 1 over 2. I've just assigned the minus to the top, which is what I normally do. It tells me that the rise is minus 1, which we know that it's really going to be a drop rather than a rise. So plotting this, we use our 2 bits of information. We start with the y-intercept. Where is it going to cross, our y-axis? Well, it's 0. So I'm going to put an x right there in the middle that is represented by 0. And then I'm going to apply my rise over run from this point on. So my rise is minus 1, which I'm going to say is a drop because we don't rise minus 1. And my run, always to the right, will be a value of 2. 1, 2. And I'm going to put my second plot in there. And if I join those 2 lines up, I'm just not going to plot any more points, but join both of those up. I end up with a line that doesn't look like that. That's awful. Let's try again. I'll try from this side. No, through there. That is the line that represents this equation of y equals minus half x. You'll notice each one of these lines only has one point one intercept. This green one here appears like it might have 2 intercepts, but it passes through 1 point in the graph. Okay, I'm hoping this has helped your understanding with remembering everything there is to drawing straight lines, and that you've gained something from doing these examples. So I'd like you now to run through all of the problems, left-hand side problems in the exercise. Again, if you do have any questions or have struggled with this perhaps a little bit and need to ask me something, then email me. That's the quickest way for me to understand that somebody needs help, and I'm more than happy to help you. So I'll leave it at that, and I'll let you get on with your problems. Let me know how you go. See you later.